So now that we know how to find limits of polynomials, the next step is for us to figure out how to do it for rational functions. So remember that a rational function is one where you have a fraction and you have polynomials in the numerator and denominator. So if, I'm going to say R is a rational function with the numerator being the polynomial p of x, the denominator being the polynomial q of x, and c is a real number with, when I plug in c, the denominator is not 0, then the limit as x goes to c of my rational function, I can just plug in. So as long as my denominator is not 0 when I plug in my value, to find this limit, I can just plug in. I can substitute. Okay, so let's look at one. Let's find the limit. The limit as x goes to 1 of x squared plus x plus 2 over x plus 1. So let's look. The value I want to plug in is 1. And we're going to look at plugging it into the denominator. Is the denominator going to be 0 if I plug it in? The answer is no. X plus 1 is not 0 when I plug in x equals 1. So what that means, again, is I can just plug in. To compute this limit, we can just do substitution. 1 squared plus 1 plus 2 for 1 plus 1, 4 over 2 or 2. So there's my limit. Now what about, we've talked about rational functions, what about if I have roots? So for example, well, I'm just going to state the general rule first. If n is a positive integer, and if n is odd, and c is any number, or if n is even, and c needs to be positive, then the limit as x goes to c of the nth root of x, you can just plug in c for x. We can just do substitution here. So the one little caveat is if n is even, so for example, if you're looking at a square root, you can't take the square root of a negative number, which is why there's this extra condition here that if n is even, c needs to be positive. So this is great. I can just substitute in for these roots, for radicals. So for example, if I wanted to find the limit as x goes to 9, the square root of x, here n is 2 because it's a square root, and 9 is positive, so I can just plug in, this would be the square root of 9, which is 3. Okay, so if we have radicals, we can also use direct substitution for those as well.